Hey guys, today we are going to continue graphing our trig functions, and we're going to talk about the last two transformations you might see, the vertical shift and the phase shift. So today we're going to ask ourselves, how do I find the vertical shift and phase shift of a general sinusoidal function? And we're still going to be dealing with sine and cosine today. So if you remember, this is that general form of my trig equation. You can replace sine with cosine, it'll still do the same thing. And so let's kind of review what each of the pieces means. So A, we're going to start with alphabetical order. So A represents your amplitude. And we talked yesterday or this weekend, whenever you watch that video, that's just the distance from the middle to the top or the bottom. So you're just thinking about how far up does it go or how far down does it go from that middle line. B, the number that's being multiplied by your theta, gives you your period, or it tells you how many degrees or radians does it go through before it completes a cycle. So remember, in order to find that period, if you're in degrees, you're going to take 360 divided by the number, so whatever B value is, or if you're in radians, you're going to take 2 pi divided by that number B. Once you have that, that's your period. In order to find those critical points, or how often do those important values happen, a high or a low or a mid, you're going to take your period and divide it by 4, because there are always 4 special points before you start repeating your cycle. Okay, so that's kind of what we talked about in the period and amplitude phase. Now we're going to talk about this C and this D. So C, the one in the front, is going to be your vertical shift. And basically what your vertical shift does is it tells you where your sinusoidal axis is going to be. So it's the location of that sinusoidal axis. And remember, the sinusoidal axis is just where the middle is. So you're just moving your graph up or down, and really all that's going to do is shift that axis in the middle, so that way we can see how far up or how far down it goes. Okay, so we're going to talk, this is middle points. And the last one that we have in here is the letter D, which is inside those parentheses, and we are going to call that a phase shift. Now, back in Algebra 2, when you did all the transformations of functions, you might have called this a horizontal shift. It really is still a horizontal shift, but what it tells us when I'm graphing a trig function is it's going to tell you the first point on your x-axis. So if it is a cosine graph, it'll be where your first high point is. If it's a sine graph, it'll tell you where your first middle point is. So really, these two pieces of information right here are just those horizontal vertical shifts from Algebra 2. And so let's kind of get some practice doing these. Okay, so we have this first equation. Y equals -3 plus 5 times the cosine of 2/3 theta plus 150. Remember, if you have a theta in your equation, usually that means you're going to graph in degrees. So we're just going to start in degrees, and we'll do some radians in a little bit. So the first thing you're going to do is name all that ABC business. So if I'm looking, remember, my general function is y equals c plus a, and this is cosine, so I'm just going to write a cosine in there, b theta minus d. Okay, so my a value is going to be the one that's in front of your trig function. So my amplitude of this graph is 5. So it goes 5 up and 5 down. Okay, the next one that we're dealing with, just going in alphabetical order, is my b. And again, your b is going to be the one that's outside your theta. So it's inside the function, but it's next to your theta. So your period is going to be 360, since we're in degrees, divided by b, which is 2/3. Okay, we got some fractions going on here. Remember, keep your first number, change your sign, flip your second number, and if you figure this out, you would get 540 degrees. So my graph takes 540 degrees to complete one cycle. After you have your period, you can find your critical points, and your critical points are going to be whatever your period is divided by 4. So a critical point is going to happen 135 degrees after the starting point, and then 135 after that, and 135 after that, etc. Okay, so that's what we did last week. Now let's talk about these phase shifts and the vertical shifts. So the first thing that you're going to do is your vertical shift, which is your C value, the one on the outside. So I see I have a -3 here for my C value, so my vertical shift is -3. This tells you that you're going to move your sinusoidal axis down to -3. And we'll graph it in a second. And then finally, we have my phase shift, which is that number that's being added or subtracted on the inside of your parentheses. And you see that that number is 150. Now, if you remember, in the equation, that has a minus sign built in. So because this one is a plus, it's opposite of what you think, your phase shift is going to be -150. And that's going to tell you the first point on your x-axis. Okay, so let's use all this information to graph this. I'm just going to draw myself a coordinate grid. Now the first thing is you always should read your directions to see how many cycles it's going to be. I'm just going to graph one cycle because it's faster, but if your graph asks, or your directions ask you to graph 2 cycles, make sure that you're doing what it says. So the first thing that I am going to do is your sinusoidal axis. Okay, that up or down shift. And so I know it's at -3. So I'm going to go down, mark off on my x or y-axis -3, and I'm just going to draw a horizontal line to tell myself that is my new middle line. Okay, the next thing that I'm going to do is think about my amplitude, because my amplitude tells me how far up or how far down it's going to go. So if I go up 1, 2, 3, 4, 5 units, that's going to put me at 2. And if I go down 5 units, that's going to put me at -8. So that's where your high points are going to lie and your low points are going to lie. The next thing that we are going to do is we're going to find that phase shift. So I'm going to label where my first point is on my x-axis. So it's at -150. And once I have that, I can use then my critical points in order to finish labeling my x-axis. So I know I'm going to take -150 and add 135 to it to get my next critical point. So that'll be at -15. Again, add another 135 to it, get 120, another 135, get 255, and my last one will be 390. So if you notice, there are 4 critical points, but I'm going to graph 1 extra, so then it kind of shows my complete cycle. Okay, at this point, I'm going to think about where my important points are. So since this is a cosine graph, we know that it starts at a high. So if it starts at a high point, I'm going to go to that phase shift, that first value, put a high point in it, 2. Then it goes down to middle. Well, you know, it helps if I put it in the right spot. Goes down to middle, goes down to low, goes back to middle, goes up to high, and I can just connect my dots, well, maybe connect my dots, and I have my graph. Alrighty, so let's try another example. This one is y equals 5 minus 6 cosine of pi over 5 times x minus 2. So one of your tip-offs that this is going to be in radians is that it has an x and not a theta. My other tip-off is there's a pi in there, and so usually that means I'm dealing with radians. Okay, so let's start with naming my ABC. So my A here, my amplitude, is going to be 6, the number on the outside. Now you notice that this is a -6. What that is going to do is make my graph reflect. Okay, so if the negative is outside of your trig function, so negative sine or negative cosine, then you are going to reflect across the x-axis. So really what that means is if you're usually at a high point, then you're going to go down to a low point and then keep doing your graph, just flip it over. Or if you started at a middle and you know you're supposed to go to a high, now you're going to go down to a low. So really all it does is flip-flop your highs and lows. So we'll do that when we graph in a second. Okay, so that is my A. Then my B, to find my period. Remember, I take that number outside the parentheses, inside the function, and I'm going to take 2 pi divided by pi over 5. Do some flippy-floppy fractions. And I would get those pi's to cancel, and 2 times 5 is just 10. Okay, which tells me my critical points are going to happen at the period divided by 4, which would get me approximately 2.5. And you can leave that as a fraction. You can do a decimal, whatever. So every 2.5 points, I'll have another critical point, critical value. Okay, so now we're going to worry about my vertical shift and my phase shift. So my vertical shift is that number outside. This is a positive 5, so my sinusoidal axis is going to move up 5. And then finally my phase shift, or where my graph starts, is going to be 2, and it's going to be a positive 2 because remember, it's opposite of what you think. So if it was a negative, it's now a positive. If it was a positive, it'll be a negative. Okay, so let's go ahead and graph that. So I am going to make my beautiful graph, and sometimes you might have to extend some of your axes. It'll be okay. So the first thing we're going to graph is my vertical shift, or the sinusoidal axis, to kind of tell myself where do I start. So that starts up at positive 5. Draw yourself a dotted horizontal line to kind of give yourself that idea. Next thing we're going to do is my amplitude. So my amplitude goes up 6. So up 6 from 5 is 11. And down 6 from 5 is at negative 1. So that's where your high and low points are going to be. The next thing that we need to do is tell myself where to start. Where's my phase shift? So my phase shift is starting at positive 2. And then every 2.5 after that, I'm going to label my axis. So I'm going to go to 4.5, 7, 9.5, and then one last point for good measure to make sure we start, or we end where we started, is at 12. Okay, now I have to do my figuring out where I'm starting. So because remember, I have a reflection. Usually cosine is a high, but because we're starting with a reflection, we're going to start at a low. And so I'm going to start at negative 2 at a low point. Then I'm going to go to the middle, go to a high, go to a middle, go to a low, and then connect my dots. Whoa, well, I tried. Okay. So that's just the reflection. We literally just flip-flopped where it was. And if I was to draw more cycles, it would look just like a cosine graph. It just starts at a low instead of a high. And one last example. This one's going to be a sine graph. Y equals negative sine of 3x plus pi over 2 plus 1. So again, I'm going to start by just labeling all the things that I need to know in order to graph this. So my amplitude. The number in front of my sine is just 1. And you notice it has a negative in the front, which means I am reflecting the sky again. Okay, and then we're going to find my period, where I take my 2 pi divided by b, and I knew it was going to be in radians because A, they used an x, and B, I see some pi's in there. Now, the thing that you notice in your y equals c plus b, well, I forgot my letters. I can't do y equals c plus a sine of b times x minus d, is when you look in here, this b is outside the parentheses. There's nothing in front of the x when it's inside the parentheses. So what I'm going to have to do here is I'm going to have to factor out these parentheses in order to make it look like the equation that I know. So I'm going to factor out that 3 in the front. And if I take out a 3 from x, from 3x, I have to take out a 3 from pi over 2. So pi over 2 divided by 3 is going to get you pi over 6. So again, when you have a number in front of your x, it has to be outside the parentheses. So you're going to have to do a little bit of tricky factoring before you can worry about what your period really is. So now I know my period is in fact 3, because you notice this affected my phase shift a little bit. So now my period is going to be 2 pi over 3. Can't simplify that, which makes my critical points 2 pi over 3 divided by 4, or times 1/4, which would get me 2 pi over 12, or every pi over 6. We're going to have a critical point. Okay, then we do my other stuff. So I have my vertical shift. You notice this one kind of flip-flopped. It's down here in the back, so don't forget about it. My vertical shift is 1 up. And then my phase shift is I look right here out in my parentheses, in my factored parentheses, and I would get that it's negative pi over 6. So my graph is going to start at negative pi over 6 because it was a plus. Okay, so let's go ahead and graph this guy. Again, start with your sinusoidal axis, which is your vertical shift. It went up 1. I'm actually going to make that a little bit bigger. Sorry about that. Since my amplitude is so small, I kind of want a bigger graph. Okay, so I'm going to start at 1. My amplitude didn't change from the parent function, so it's just going to go up 1, so down up to 1 and down to 0. And now I'm going to plot my phase shift. So my phase shift is at negative pi over 6 is where that first point is going to start, then 0, then pi over 6, and then 2 pi over 6, which is actually equivalent to pi over 3. You can simplify your fractions here. 3 pi over 6, which again is equivalent to pi over 2. And that'll get me 1 cycle. Remember, you can always keep going and keep finding more points if you needed to graph 2 cycles. And again, simplify if you can. Oh, that should be 6. I don't know how to math today. So that's going to be 1 pi. And then, whoa, hey, that was rude. And then finally 7 pi over 6 would get me 2 complete cycles. So now I'm going to think about where my high, low, middle points are. So since I have sine usually starts at a middle point. So he still gets to start at a middle point. But now because there's a reflection, instead of going up and making the regular graph, he's going to go down and get to a low point. Then a middle point, then a high point, then a middle point, then a low point, middle point, high point, middle point. Connect your dots. And that's going to start where it's stop where it started, and you have 2 complete cycles of this sine graph. Hope you guys have a great night.